Good morning. Thanks for clover leaf, Alex. In embryo stage, there are more than 100 myoblasts continuous division. In embryo, there are greater than or equal to 100 myoblasts continuous division. Continuous division form single skeletal muscle. After fusion, multinucleated muscle fiber. Muscle fiber is multinucleated. Okay. Syncytium सेल के फ्यूजन होगी न्यूक्लियस मोर देन वन syncytium. Okay. In embryo stage, there are more than or equal to 100 myoblasts continuous division form single skeletal muscle. In embryo, there are more than 100 myoblasts which undergoes continuous division and form a single skeletal muscle. Embryo stage, 100 myoblasts form single skeletal muscle which is multinucleated muscle fiber. Structure of muscle tissue. First, that is muscle fiber. This is muscle, muscle, muscle. Okay. Fascia, collagen fiber present around, okay, present around fascicle. These are fascicle. This is muscle, these are fascicle. fascicle. Okay, fascicle, 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 F-A-S-I-C-L-E, fascicle, ties or binds fascicle together, okay, fascia. क्यों से इसको करी fascia, this is a fascia. These are fascia, F-A-S-C-I-A. These are fascia, okay. This is muscle, fascicle, F-A-S-I, fascicle, fascia is the collagen fiber, fascia, collagen fiber, collagen fiber binds fascicle together, fascia, collagen fiber bind fascicle together, binds fascicle together, okay. मसल भित्र के हुन्छ फ्यासिकल बन्डल हुन्छ, फ्यासिकल बन्डललाई फ्यासियाले बाइन्ड गरेको हुन्छ, फ्यासिया फ्यासिकल, ओके, फ्यासिकल बन्डल हो, फ्यासिया के हो, कोलाजन फाइबर. Covering muscle, epimysium, okay, dense irregular connective tissue, epimysium, epimysium, fascia, okay, muscle, covering epimysium, dense irregular connective tissue, okay, dense irregular connective tissue. Connective tissue. Fascia, collagen fiber present around fascicle. Ties fascicles together. Covering epimysium. Dense irregular tissue. Epimysium. Dense irregular tissue. Okay. Dense irregular tissue. Perimysium. Epimysium. And this is perimysium. Perimysium. Muscle fiber, perimysium, muscle fiber, fascicle को भित्र muscle fiber, perimysium ले cover गरेको हुन्छ के. Sarcoplasm many nuclei. Sarcoplasm many nuclei, okay. Sarcolemma multinucleated. Sarcoplasm and sarcolemma multinucleated muscle fiber. Covering of the muscle fiber, endomysium, epimysium, perimysium, and this is endomysium. Endomysium, this is sarcoplasm, sarcolemma, multinucleated, sarcolemma, endomysium, sarcoplasm, sarcolemma, Endomysium, this is endomysium. Sarcomere, multinucleated. Adamantium covering, okay. Muscle fiber, sarcolemma multinucleated. Muscle fiber, sarcolemma multinucleated, covering of muscle fiber, endomysium, covering of muscle fiber, endomysium, covering of muscle fiber, endomysium, muscle fiber, okay. Muscle fascicle, fascicle को भित्र फ्यासिया हुन्छ कोलाजन फाइबर, जसले फ्यासिकललाई बाइन्ड गरेको हुन्छ, त्यसको भित्र हुन्छ मसल फाइबर, के मसल फाइबरलाई पेरिमाइसियमले कभर गरेको हुन्छ। फ्यासिकलको बन्डलभित्र के हुन्छ मसल फाइबर, ओके। फ्यासिकलको बन्डलभित्र के हुन्छ मसल फाइबर हुन्छ, पेरिमाइसियमले कभर हुन्छ। इट इज अ बन्डल अफ मसल, फ्यासिकल बन्डल अफ मसल, बन्डल मसल फाइबर। मसल फाइबरको बाहिरबाट एन्डोमाइसियम, इपिमाइसियम, पेरिमाइसियम एन्ड एन्डोमाइसियम भित्र के हुन्छ सार्कोलेमा मल्टिन्युक्लिएटेड हुन्छ। सार्कोप्लाज्म पनि के हुन्छ मल्टिन्युक्लिएटेड हुन्छ के। myofibrils, these are myofibrils. सर्कोलेमा र सार्कोप्लाज्म दुईटै मल्टिन्युक्लिएटेड हुन्छ। यसलाई के भन्छ यसलाई भन्छ मसल myofibrils, myofibrils, FIBRILS, myofibrils, FIBRILS, 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 myofibrils. 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 Sarcomere and nuclei. Myofibrils. myofibrils के हुन्छ न त फर्स्टमा नि डिफ्रेन्ट कुरा हुन्छ के। फर्स्टमा के हुन्छ भन्दाखेरि चाहिँ मसल बन्डल हुन्छ। मसल बन्डलको भित्रपट्टि फ्यासिकलको लाई वरिपरि कोलाजन फाइबर, फ्यासिया कोलाजन फाइबर जसले बाइन्ड गर्छ फ्यासिकललाई, के। फ्यासिकलको भित्र के हुन्छ भन्दाखेरि चाहिँ नि fascicle, these are fasciola, these are fasciola, okay. Fascicle, fasciola, fascicle bundle को भित्र के हुन्छ न त fascicle bundle को भित्र हुन्छ। This is muscle. Fascicle bundle को भित्र यसको कभरिङ लाई भन्छ इपिमाइसियम, dense irregular connective tissue, dense irregular connective tissue. muscle fiber. Muscle fiber. These are perimysium. Muscle fiber, perimysium. Okay, perimysium muscle fiber. Muscle fiber la nikali rehni. Sarcoplasm, sarcolemma. Both are multinucleated. Multinucleated. There are myofibrils. These are myofibrils. Myofibrils. VRILS. Myofibrils. Okay. Myofibrils are darker endomycelium. Endomycelium. Endomycelium covering. Sarcoplasm, many nuclei. Okay. Myofibrils, dark and light band. Myofibrils floating in SP. Floating in sarcoplasm. Myofibrils, dark and white band. Okay, dark and white band. It is floating. Myofibrils is floating in sarcoplasm. Actin and myosin. Actin thin, myosin thick. Actin and myosin fiber. Actin thin, myosin thick. Myosin thick. Thin filament and thick filament. Actin thin filament, myosin thick filament. Actin is 3000, myosin 1500. 1500 myosin, actin 3000. In single sarcomere, half I plus E, half I. Each actin thin, surrounded by 3 myosin. 3 myosin. Each myosin surrounded by 6 actin filament. Okay, actin filament. Each actin is surrounded by 3 myosin filament. Each actin is surrounded by 3 myosin filament, whereas each actin is surrounded by 3 myosin. Each myosin is surrounded by 6 actin filament. Each actin surrounded by 3 myosin. Each actin is surrounded by 3 myosin. One actin surrounded by 3. One actin surrounded by 3 myosin. 1, 2, 3. Okay. Each actin is surrounded by 3 myosin. Whereas each myosin is surrounded by 6 actin. Okay, actin filament. During complete contraction of muscles, length of sarcomere decreases, length of eye band decreases, length of edge zone disappear during complete contraction. M line, center line disappear during complete contraction. M line disappear. Length of O band increases, length of A band unchanged. Length of A band unchanged. Okay. During complete contraction of muscles, length of sarcomere decreases, length of eye band decreases, length of edge zone disappears during complete contraction. M line disappears, edge zone and M line disappears, eye band and sarcomere decreases. Length of O band increases, length of A band Length of A band, length of A band unchanged. Length of O band increases during muscle contraction. During muscle contraction, length of I band decreases. Length of sarcomere decreases. At June, disappear during complete contraction. DISA or DISSA? DISA. Disappear during complete contraction. At June disappears during complete contraction. At June, okay. M line disappear during complete contraction. M line disappear. Length of I band decreases. Length of sarcomere decreases. At June disappears. M line disappears. A band remain unchanged. Length of A band unchanged. Length of I band, is it I band? O band. O band increases. Length of O band increases. Length of E band unchanged. Length of adjoint disappears. M line, central line disappears. Length of I band decreases. Length of sarcomere decreases. Okay. M line, thin fibrous membrane. M line is thin and fibrous membrane. Thin M line, thin fibrous membrane. Thin fibrous membrane. Okay. Thin fibrous membrane. M line, thin fibrous membrane. Length of sarcomere decreases. Length of I band decreases. Length of S zone disappears during complete contraction. M line, central line disappears. Okay. Length of O band increases. Length of A band unchanged. Length of A band unchanged. M line, thin fibrous membrane. Structure of contractile protein. Structure of contractile protein. Force generating protein, regulating protein, and structural protein. Structure of contractile protein. There are three types of contractile protein: force generating protein, regulating protein, and structural protein. Structure of contractile protein. STRUCTL, structure of contractile protein. Structure of contractile protein. Regulating protein. Regulating protein. Okay. Regulating protein. Then the other two is structural protein. Structural protein. Regulating protein, structural protein. एउटा के हो रेगुलेटिङ प्रोटिन हुन्छ, अर्को के हुन्छ स्ट्रक्चरल प्रोटिन हुन्छ, अझै एउटा के हुन्छ त रेगुलेटिङ प्रोटिन, स्ट्रक्चरल प्रोटिन एन्ड फोर्स जेनरेटिङ प्रोटिन. फोर्स जेनरेटिङ प्रोटिन, फोर्स जेनरेटिङ प्रोटिन, रेगुलेटिङ प्रोटिन एन्ड स्ट्रक्चरल प्रोटिन. structure of contractile protein. Force generating protein हुन्छ, regulating protein हुन्छ र contractile protein हुन्छ. Contractile protein हुन्छ, के हुन्छ? Force generating protein, contractile protein र structural protein. Force generating protein दुईटा टाइपको हुन्छ, actin thin, myosin thick. Actin and myosin are force generating protein. Actin is thin, myosin is thick. Okay. Regulating protein, tropomyosin and troponin. Tropomyosin and troponin both are part of thin filament. These are regulating protein and both of them are the part of regulating protein. Yes, now thin filament, both are part of thin filament. Tropomyosin and troponin. Tropomyosin and troponin, regulating protein. Structural protein, Z line, elastic fiber present in Z line. Structural protein, Z line, elastic fiber present in the center of I band. Present in the center of the I band. Present. It's okay. I band को center में located. I band को center में located हुन्छ. Elastic fiber, Z line is protein, Z line protein, elastic fiber present in center of the I band. Tropomyosin and troponin both are part of thin filament. Both are part of thin filament. Okay. First we have force generating protein. Number one is force generating protein, myosin, thick filament. Then actin, myosin, actin and myosin, actin thin. Actin and myosin are force generating. Actin and myosin are force generating. Regulating protein are tropomyosin. Tropomyosin and troponin. Tropomyosin. Tropomyosin. Tropomyosin and tropomyosin. Okay, troponin ra tropomyosin. Tropomyosin. Tropomyosin and troponin. Both are part of thin filament. Part of thin filament. Troponin ra tropomyosin. Troponin ra tropomyosin. Okay. Structural protein. Z line. Structural protein, Z line protein, elastic fiber present in the center of I band. Present in the center of I band. Elastic fiber, Z line protein. Structural protein, Z line protein, elastic fiber present in the center of the I band. Present in the center of the I band. Okay, SOFG is structure of what is this? SOFGP. Structure of functioning. Structure of contractile protein. Then mechanism of muscle contraction. ये तो नहीं होगा. GP, actin and myosin. RB. Contractile protein. अच्छा, structure of functional force generating protein. इसको ना ऐसे करते हैं. Structure of force generating structure of force generating protein. Okay, structure of force generating protein, actin and myosin. Actin, globular actin, filament actin. Okay, globular actin in the presence of Mg2 plus magnesium ion. In the presence of magnesium ion, it turns into polymer F actin, that is filament. Actin filament. Okay. globular actin turns into filament F-actin polymer, which is polymer in the presence of Mg2 plus. Myosin 300, polymer of 300 meromyosin, unit of myosin, meromyosin, okay. Polymer of 300 meromyosin, okay. Polymer of 300 meromyosin, unit of myosin. Polymer of 300 meromyosin, unit of myosin. This is unit of myosin, okay. Myosin 300, polymer of 300 meromyosin, unit of myosin. Actin filament, globular head, actin binding site, ATPase enzyme, ATP binding site, ATPase enzyme, ATP binding site, actin binding site, actin filament, globular head. There are two sites. One is for actin binding site, other one is ATPase enzyme binding site. ATP binding site, okay. ATPase enzyme, ATP binding site. Polymer of 300 meromyosin, unit of myosin. Polymer of 300 meromyosin, unit of myosin. Actin filament, globular head. Neck or short arm, globular head, neck or short arm. Cross arm, heavy meromyosin. Monomer of myosin, meromyosin. Monomer of myosin, meromyosin. Polymer of 300 meromyosin. Monomer of myosin, meromyosin. Monomer of myosin के हुन्छ meromyosin हुन्छ, okay. Unit of myosin. Polymer of 300 meromyosin. Actin filament हो यो. Neck or short arm, tel equals to 2 unit. Light meromyosin, tel like it's a light meromyosin, 2 unit. Light meromyosin, heavy meromyosin, cross arm. Cross arm is heavy meromyosin, that is neck or short arm, and globular head. Total number of unit in meromyosin. Total number of meromyosin 2 plus 2, 4, 5, 6. Okay. Total unit of meromyosin 6. Total tel unit is equals to 2. Light meromyosin. Heavy meromyosin is cross arm. Globular head, neck or short arm. Actin filament, actin binding site, ATPase enzyme, actin binding site. Polymer of 300 meromyosin. Myosin is polymer of 300 meromyosin. Unit of myosin. Monomer of myosin, meromyosin. Structure of force generating protein. Force generating protein. Structure of force generating protein. Structure of force generating protein. Actin, myosin. Globular actin in the presence of Mg2 plus becomes filamentous actin. This is globular actin. Filamentous actin, filament. This is actin, filament. Nerve, actin, filament, globular, actin, globular, actin, filamentous actin, okay, filamentous actin, MC plus myosin. Globular head and short arm, also known as cross arm, is equals to 4 unit. Heavy meromyosin, HMM, okay. Globular head, short arm or neck, ATPase enzyme, ATP binding site, ATPase enzyme, ATP binding site. This is tell reason. Tell heavy, this is light meromyosin. Light meromyosin, light meromyosin, short arm, cross arm, okay. 2 unit, total unit of meromyosin. Myosin is equals to 6. Meromyosin, okay. Actin binding site, ATPase enzyme. Actin binding site, ATPase enzyme site, ATPase enzyme site, actin binding site, ATPase enzyme site. इसको ना ऐसे कर देते हैं. Actin binding site और actin binding site. Actin binding site, ATPase enzyme, ATP binding site, okay. Globular head, 2 unit, neck, short arm or neck, 2 unit. This is 2 unit. 2 unit. Cross arm. Heavy मेरो myosin HMM 4 unit. 10. 2 unit light मेरो myosin. Total unit of मेरो myosin 6. Okay. मेरो myosin. Monomer of मेरो myosin. Monomer of tel is monomer of मेरो myosin. Monomer of myosin. Myosin को monomer लाई के भन्छ मेरो myosin. Myosin को monomer लाई myosin मा total 300 मेरो myosin. Polymer of 300 मेरो myosin. Unit of myosin. 300. Polymer of 300 मेरो myosin. Unit of myosin. Okay. Monomer of myosin मेरो myosin. Myosin को monomer के हो मेरो myosin. जसमा 300 मेरो myosin जोडेर बनेको हुन्छ. Structure of regulating protein. Structure of regulating protein. Tropomyosin and troponin. Structure of regulating protein. Tropomyosin and troponin. Two filaments of tropomyosin run closely. Two filaments of tropomyosin run closely along with actin filament and inhibit interaction of actin and myosin. Two filaments of tropomyosin. Two filaments of tropomyosin run closely along with actin filament and inhibit interaction of actin and myosin. Tropomyosin, troponin. Two filaments of tropomyosin run closely along with actin filament and inhibit interaction of actin and myosin. Troponin. Structure of regulating protein. Structure of regulating protein. Tropomyosin and troponin. Two filaments of tropomyosin run closely along with actin filament. Two filaments of tropomyosin run closely along with actin filament and inhibit interaction of actin and myosin. Okay. Regulating protein returns. The first one is tropomyosin, troponin. Tropomyosin, troponin. Tropomyosin. Two filament. Two filament of tropomyosin run parallel to actin filament. Tropomyosin. Two filament of tropomyosin run parallel to actin filament, inhibit interaction of Inhibit interaction of tropomyosin. Tropomyosin. Inhibit interaction of tropomyosin. I know allow it. Inhibit interaction of actin. Inhibit interaction of actin with myosin. Myosin. These are the two functions. Two filaments of tropomyosin run closely along with actin filament with actin filament and inhibit interaction of actin with myosin. Inhibit interaction of actin and myosin. Inhibit interaction of actin and myosin. Inhibit interaction of actin and myosin. Troponin. It is a complex protein. Troponin is complex protein. 3 units, which is present on tropomyosin at regular interval. 3 unit. Troponin has 3 unit. Has 3 unit complex protein. Has 3 unit. Troponin has 3 unit complex protein. Okay. At regular interval of present on tropomyosin. It is present on tropomyosin at regular interval. TPC, TPT and TPI. TPC, calcium binding troponin. Troponin, okay, TPC, TPI, CTI. Calcium binding troponin. Troponin binding tropomyosin binding troponin. Tropomyosin binding troponin and TPI inhibit interaction of actin and myosin. Inhibitor binding troponin. Inhibit interaction of actin and myosin. Inhibit interaction of actin and myosin. Structure of regulating protein. Okay. Troponin has 3 units. They are complex protein present at regular interval. In tropomyosin. Present on tropomyosin at regular interval. There are few types. One, TPC, TPT and TPI. This is calcium binding site. Troponin with calcium binding site. Calcium binding troponin. This is tropomyosin binding troponin. Tropomyosin binding troponin and inhibitor binding troponin. Inhibitor binding troponin inhibit the reaction or inhibit interaction of actin with myosin by masking of active site of actin. Okay. TPC. Calcium binding troponin. TPT. Tropomyosin binding troponin. TPC, TPT and TPI. Inhibit binding of actin with myosin. Inhibit binding of actin with myosin. TPC, TPT, and TPI. Troponin, calcium binding troponin. Tropomyosin binding troponin. Troponin, okay. Inhibit binding of actin with myosin by active masking. Active inhibitor binding troponin. Inhibitor binding troponin by active masking of actin. By active masking of actin filament. By masking of active site of actin. 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 This one is actin filament, calcium binding TPC, TPT, tropomyosin binding troponin, and finally here is TPI. Okay. TPI inhibits binding of myosin with actin by masking active site of actin. These are these three are 3 unit of troponin. 3 unit of troponin. TPI inhibitor, TPT. Calcium binding. This is okay. Here we have TPT, TPC, okay, TPC, TPI, and TPT, troponin binding. TPT, troponin binding troponin, tropomyosin binding troponin, and this is TPI by masking active site of, this is actin, okay, actin. Here we have myosin. This is myosin, okay. Tropomyosin binding troponin. First ma ke garcha tropomyosin lies tropomyosin two filament of tropomyosin run closely along with actin filament. Two filament of tropomyosin run closely along with actin filament and inhibit interaction of actin and myosin. इसको तकलीफ function TPT को run closely, closely with actin filament, okay. The inhibit interaction of actin and myosin. Inhibit interaction of actin and myosin. Structure of force generating protein, actin and myosin. Force generating protein. A structure of regulating protein, that is tropomyosin and troponin. A structural protein, Z line. Structural protein, Z line, okay. Structural protein, Z line. motor unit, motor neuron, skeletal muscle, skeletal muscles, neuromuscular junction or motor end plate, neuromuscular junction or motor end plate, neuromuscular junction, motor end plate. N-E, new, N-E-U, N-E-U or neuromuscular junction, neuromuscular junction, motor end plate, motor end plate, neuromuscular junction, motor end plate, neuromuscular junction or motor end plate. Motor unit, okay. Skeletal muscles, motor neuron, neuromuscular junction or motor end plate, motor neuron. Myoglobin, red protein, more in red fiber than white fiber. Myoglobin, red protein. Myoglobin is red protein, okay. Hmm. Red protein more in red fiber than white fiber. Myoglobin, red protein more in myoglobin, red protein. Myoglobin like भन्छ red protein. अघि हामीले के पढ्यो, मेरो मायोसिन पढ्यो, मायोसिन पढ्यो. Myoglobin के हो, red protein, okay. Myoglobin is red protein. Myofibrils गरेको छ के, muscle fiber, myofibrils, actin र myosin हुन्छ. Myofibrils को भित्र के हुन्छ, actin र myosin हुन्छ, okay. मोटर न्यूरन, मोटर न्यूरन, न्यूरन र स्केलेटल मसल को बीचमा के हुन्छ, जंक्शन हुन्छ. कुन चाहिँ जंक्शन हुन्छ भन त, मोटर र स्केलेटल मसल्स को बीचमा, मोटर न्यूरन र स्केलेटल मसल्स को बीचमा न्यूरोमस्कुलर जंक्शन या फिर मोटर एंड प्लेट हुन्छ. मोटर एंड प्लेट या फिर न्यूरोमस्कुलर जंक्शन हुन्छ. मायोग्लोबिन रेड प्रोटीन, मायोग्लोबिनलाई के भन्छ, रेड प्रोटीन, मोर इन रेड फाइबर देन व्हाइट फाइबर. व्हाइट मसल मोर फटिग, रेड मसल more work without fatigue, okay. Myoglobin, red protein, which is more in red fiber than white fiber. White muscles more fatigue, red muscles can work more efficiently without fatigue, okay. Red fiber, red fiber or red muscle, muscle. More efficiently without fatigue. Red muscles can work more efficiently without fatigue. White muscle more fatigue due to absence of white protein, due to absence of more fatigue due to absence of can work more efficiently without fatigue, more fatigue due to absence of red muscles can work more efficiently without fatigue. White muscles more fatigue due to absence of red protein. More work without fatigue, more fatigue. red protein, more in red fiber than white fiber. Okay. Okay. We have this motor neuron. This is motor neuron. Motor neuron. Motor neuron. Motor neuron. Okay. Motor end-plate or neuromuscular junction. Motor end-plate or motor end-plate or neuromuscular junction. Motor end-plate. Okay. Motor neuron, motor end-plate or neuromuscular junction. This is skeletal muscle. Depolarization or impulse. Depolarization or impulse. Motor neuron. Depolarization or impulse. Here we have calcium ion. Depolarization or impulse. Breakdown of calcium ion. Exo calcium channel, voltage gated channel open. Calcium channel or voltage gated channel open. Voltage gated channel open. 3. Exocytosis of neurotransmitter. Exocytosis of neurotransmitter. Break. Impulse Ca2 plus ion. Motor neuron. We'll take a break, okay? First slot completed. मैं लिख भी देती हूँ ब्रेक करके. हाय निधि, मुझे ना ये ऑफ़ करना पड़ेगा. 5 मिनट का ब्रेक है ना, लेकिन मैं इसे ऑफ़ कर रही हूँ, ओके? क्योंकि ना मुझे पता है लोग ना कुछ गंदा बोलेंगे. उन लोग ना यूट्यूब को हवस झाड़ने की प्लेटफॉर्म जैसा दिखाते हैं. तो मैंने ऑफ़ कर दिया, ओके? लेकिन मैंने तुम्हें देखा निधि, यू आर देयर. Break over. I'll set the timer for 60 minutes again. Good luck, everyone. calcium channel, voltage gated channel open. Calcium channel, voltage gated channel, voltage gated channel open. VGC. Calcium channel VGC, voltage gated channel open. Motor and plate or neurotransmitter. Okay. Neuron. Motor neuron, this is impulse generation. Impulse depolarization or depolarization. Depolarization, that means impulse generation. Impulse generation, depolarization. Depolarization. Calcium channel, voltage gated channel open. Calcium channel. Voltage gated channel open. Open. Calcium channel open. Okay. This is how voltage gated channel. Motor neuron, impulse generation, depolarization or impulse generation. Calcium ion, Ca2 plus. Calcium channel open. Calcium channel open. Calcium ion enters neurotransmitter breakdowns. Exocytosis of neurotransmitter. Voltage gated, okay, polarization. Voltage gated channel, calcium channel open. Calcium enters. Okay, this is exocytosis of neurotransmitter. Neurotransmitter. Exocytosis of neurotransmitter. Exocytosis of neurotransmitter. Astaghfirullah. Exocytosis of neurotransmitter. Exocytosis of neurotransmitter. This is exocytosis of neurotransmitter. Okay. Then fourth option. Receptor of acetylcholine open. ACH. Receptor of acetylcholine ACH open. Sodium channel. Ligand gated channel. First, impulse generation or polarization. Impulse generation or polarization. First option is impulse generation or polarization. Then second option is impulse generation or polarization. Calcium channel, voltage gated calcium channel opens. Third, exocytosis of neurotransmitter. Fourth, sodium channels, ligand gated sodium channels opens. Ligand gated sodium channel opens. Sodium channel ligand gated channel opens. Receptors of acetylcholine ACH. Receptors of acetylcholine. Okay. Exocytosis of neurotransmitter. Okay, so these are acetylcholine. I think so. ACH. They have receptors of ACH opens sodium channel. Receptors of ACH. Okay. ACH receptors. Okay. Receptors of ACH. ACH. Receptors of ACH opens ligand gated channel for sodium channel, and then ligand gated channel LGC. Receptors of acetylcholine ACH. Receptors of ACH acetylcholine. Receptors of ACH acetylcholine. acetyl हजुर
संसारी पूजाको पैसा उठाउँदैछ कि
मेरो त पैसा छैन चिठी गर्छ आमा भन्छ आमा तर बेलुका आउनुहुन्छ नि
त्यसो पनि
हजुर कति हो
आफ्नो मर्जी
तर यो त साह्रै कम्ती
150 100 कसैले 200 दिन्छ कसैले 100 दिन्छ 150 बेसी छ
150 त पुग्दैन होला भरे आमा आउनु भयो भने मिल्छ नि आउनुहुन्छ तपाईँ बेलुका
नाम के हो
तीर्थरञ्जी
नानीले उदर गर्नु म त्यहाँबाट चाहिँ भन्छु कि म नाम चाहिँ लेखिदिन्छु ल तीर्थरञ्जी छेत्री
acetylcholine. Receptors of ACH opens ligand gated channel for sodium channel. Motor end plate or neuromuscular junction. Exocytosis of neurotransmitter. Motor end plate or neuromuscular junction. Acetylcholine receptors of ACH opens ligand gated channel for any sodium channel. Ligand gated channel. Receptor of acetyl ACH opens sodium channel opens. Okay. Acetylcholine receptors of ACH opens ligand gated channel for sodium opens. Depolarization of impulse. Depolarization voltage gated channel, calcium channel open. Motor neuron. Exocytosis of neurotransmitter. Motor end plate or neuromuscular junction. Motor end plate. Motor end plate or neuromuscular junction. Release of acetylcholine. Breakdown of ACH by Acetylcholinesterate ACHE. Breakdown of acetylcholine by acetylcholinesterate ACHE. Receptors of ACH opens LGC ligand gated channel. Receptors of ACH acetylcholinesterate ACHE. Receptors of ACHE acetylcholine. Breakdown of ACH by cholinesterate ACHE. Release acetylcholine. Breakdown of ACH acetylcholine by acetylcholinesterate. Breakdown of ACH acetylcholine by acetylcholinesterate. Acetylcholinesterate. Okay. Exocytosis. Release of acetylcholine. Release of acetylcholine. Receptors of ACH opens ligand gated channel for sodium. Receptors of acetylcholine opens receptors of acetylcholine ACH opens ligand gated channel for sodium channel. Depolarization of impulse. Depolarization of impulse. Impulse. Depolarization of impulse. Voltage gated channel open. Breakdown of ACH by acetylcholinesterate ACHE. Depolarization or impulse Ca2 plus. Motor neuron, motor in plate or neuromuscular junction. Acetylcholine. Breakdown of ACH by acetylcholinesterate ACHE. Depolarization of impulse, positive inside, negative outside. Okay. Depolarization. Receptors of acetylcholine NACH open. Okay. Tubules, T tubules. These are called T tubules, and there are T tubules and L tubules. Okay, this one is T tubules. L tubules, storehouse of calcium ion. There is something like this. T tubules. T tubules. These are T tubules and this is L tubule. Tubule. T-U-B-U-L-E. T tubule, L tubule. Storehouse of calcium ion. Storehouse of calcium ion. Storehouse of calcium ion. Sarcoplasmic reticulum. Sarcolemma. Muscle fiber. Okay. This is sarcolemma. 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 The inside one is sarcoplasm. Sarcoplasmic reticulum. Sarcoplasmic. Plasmic reticulum. Sarcoplasmic reticulum. Storehouse of calcium ion. Muctin. Storehouse. L tubule is T tubule. L tubule is storehouse of calcium ion. Storehouse of calcium ion. I think it should be. It is. That means this. T tubules, L tubules, storehouse of calcium ion. L tubules, storehouse of calcium ion. Sarcoplasmic reticulum, sarcolemma. Sarcoplasmic reticulum, sarcolemma. Sarcoplasm, myofibrils are present. Storehouse of calcium ion. Sarcoplasmic reticulum, sarcolemma. Sarcoplasm, myofibrils are present. This one is sarcoplasm. Myofibrils are present. Okay. Sarcoplasm. PLESM. Sarcoplasm. Myofibrils. Okay. Myofibrils. That is muscle fiber. Myofibrils. Muscle fiber. Inside muscle fiber. Myofibrils. Muscle fiber. Myofibrils. Muscle fiber. Myofibrils. Sarcoplasm. Myofibrils. Contains myofibrils. Fibrils. Fibrils. Sarcoplasm contain myofibrils. Okay. Sarcoplasm contain myofibrils. Senpai. Sarcoplasm contains myofibrils. Depolarization or impulse. First depolarization or impulse generation, then calcium voltage gated calcium channel opens, calcium enters in the motor neuron. Exocytosis of neurotransmitter acetylcholine, release of acetylcholine. Acetylcholine is breakdown by ACHE, acetylcholinesterate. Okay, there are receptors of acetylcholine present in the sarcolemma. present in sarcolemma. Okay, receptors open ligand-gated channel for sodium ions. Sodium ions enters. Then fifth point, depolarization of impulse. Depolarization of impulse. Depolarization of impulse. There is T-tubule, sarcolemma, sarcoplasm, and sarcoplasmic reticulum, which is storehouse of calcium ion. Storehouse of calcium ion. Sarcoplasmic reticulum. Sarcoplasmic reticulum. Okay. Sarcoplasmic reticulum. T-tubule and L-tubule. This one is T-tubule. L-tubule. L-tubule is the storehouse of calcium ion. L-tubule is storehouse of calcium ion. Okay. Storehouse of calcium ion. L-tubules are storehouse of calcium ion. Sarcoplasmic reticulum. Sarcolemma. Sarcoplasm. In sarcoplasm, sarcoplasm contains myofibrils. Myofibrils are present in sarcoplasm. Calcium channel VCG. Voltage gated calcium channel opens once again in sarcoplasmic reticulum. VCG. Calcium enters, comes out, okay. Channel, voltage gated channel open. Calcium comes outside. Ca2 plus, okay. Ca2 plus comes outside. Ca2 plus comes outside. This is our sixth point. Yes. Calcium channel, CHANNL channel opens. Depolarization arrives here. Therefore, positive. Calcium channel opens. Calcium या nearby rounds Ca2 plus. Okay. A voltage gated channel. Calcium channel opens. L-tubule, storehouse of calcium ion. Sarcoplasmic reticulum. Sarcolemma. Sarcoplasm, myofibrils are present. Calcium channel, voltage gated channel 6. Okay. Calcium channel open, voltage gated channel. Then we have binding of calcium 2 plus with TPC. Troponin binding. Calcium binding troponin. Binding of calcium with TPC. Final Ca2 plus and Ca2 plus. There we have this TPC. Binding of calcium ion with TPC. Binding of calcium ion with TPC. Troponin, calcium binding troponin, TPC. Binding of calcium with TPC. Muscle contraction starts. Last is 8. And finally, muscle contraction starts. Muscle contraction starts. STARTS starts. Muscle contraction starts. Okay. Still okay. Depolarization. Depolarization or impulse generation. Depolarization or impulse generation. Voltage gated calcium. Voltage gated channel opens for calcium ion. This ion. Exocytosis of neurotransmitter. Process of neurotransmitter. Neurotransmitter. ACH, acetylcholine breakdown by ACHE, acetylcholinesterase enzyme. Okay, exocytosis. Then again, exocytosis of neurotransmitter ACHE. Exocytosis of neurotransmitter ACHE. Okay, depolarization. Voltage gated channel opens for calcium ion. Exocytosis of neurotransmitter ACHE breakdown. Uh, Exocytosis of neurotransmitter ACHE breakdown. Then we have ligand gated channel opens for sodium ion. Any ion, sodium ion. Okay, ligand channel receptors of sodium ion. Sodium receptors of ACH. Okay, receptors of ACH opens. LGC opens for sodium ion. Ligand gated channel open for sodium ion. Receptors of ACH opens. Ligand gated channel for sodium ion. Depolarization of impulse. Either positive, pyrapody, negative. We have T tubule, TUPULE. Depolarization of impulse. T tubule. Sarcolemma. Like even sarcolemma pani means. Okay. There is then the sixth step is depolarization. That means sarcolemma. There is sarcoplasm. Sarcoplasm. Sarcoplasmic reticulum has L tubule storehouse of calcium ion. Storehouse of calcium ion. Storehouse of calcium ion. Okay. কি করছ দেখে সার্কোপ্লাজমিক রেটিকুলাম L tubules हुन्छ storehouse of calcium ion. Calcium ion को 6 है ना point. Yes, calcium ion comes out in sarcoplasm. Calcium ions comes out in sarcoplasm. Calcium ion comes out in sarcoplasm. Sarcoplasm में क्या होता है? Calcium ion होता है. Okay. Then we have binding of calcium ion with TPC, troponin for calcium binding troponin binding. Muscle contraction starts. Okay, after that muscle contraction starts. ACE, acetyl CHOLE cholinesterate, choline CHOLENAS cholinesterate, acetylcholinesterate. That's okay. Acetylcholinesterate, acetylcholinesterate, okay. ACHE, acetylcholinesterate, ACHE. Muscle contraction starts. Binding of Ca2 plus ion, TPC. Troponin for calcium binding. ACHS, that cholinesterate, okay. Relaxation of muscle. Activation of calcium pump. Calcium level in sarcoplasm decreases. Relaxation of muscles. Activation of calcium pump, okay. Calcium ला फिर pump कर रहे हैं अंदर से. Calcium pump, okay. There is one of this thing. Calcium pump, okay. Relaxation of muscles, activation of calcium pump ले खींचे रहे भितराल दें, okay. Calcium pump, activation of calcium pump. Ca level in sarcoplasm decreases. Breakdown of ECH, acetylcholine by ACHE, acetate plus choline बनिंदर साथ. Relaxation of muscles and so. Okay. Then sliding filament theory. Relaxation of muscle. Relaxation of muscles. Relaxation of muscles. Okay, relaxation of muscles. Breakdown of breakdown of ACH. ACH, ACHE, acetyl plus choline, CHOLINE, acetyl plus choline, acetate plus choline, acetate, TAT, acetate, okay, acetate plus choline. Here we have relaxation of calcium pump, calcium pump, activation of calcium pump, C2 plus back to pump back to sarcoplasmic reticulum, L tubule, Ca2 plus pump back to L tubule of sarcoplasmic reticulum. Calcium ion decreases in sarcoplasm, plasm muscles relaxation, TATIN, relaxation of muscles, tenth, relaxation of muscles, relaxation of muscles. Acetylcholine. Sea level in sarcoplasm decreases. Breakdown of ACHE, acetate plus choline, sliding filament theory. CA level in sarcoplasm decreases. Okay. Sliding filament theory finally. Okay. There are types of muscles and limbs. Sliding filament theory. Thin fibers slide on thick filament. Thin fibers slide on thick filament. Really? I think so. Thin filament slide on thick filament. TPC, calcium binding troponin, tropomyosin binding troponin, and inhibitor binding troponin, which inhibit the binding of myosin and actin. In myosin, there is ATPase, which is responsible for the production of ATP, and in actin, there is a binding site. Magnesium ion, calcium ion, and ATP is required for the binding of myosin and actin. Formed a cross bridge. That was cross arm. This one is cross bridge. Formation of cross bridge. Initiate contraction of muscles. Formation of cross bridge. Initiate contraction of muscles. Formation of cross bridge initiate contraction of muscles. Formation of cross bridge. Initiate contraction of muscle. Initiate contraction. Initiate contraction of muscle. Cross bridge. Initiate contraction of muscles. Formation of cross bridge. Initiate contraction of muscles. Okay. Calcium Mg2 plus and roll कर रहे हैं सबको चैनल माथी करेंगे सर ATP breakdown ATP plus B high energy phosphate formation of cross bridge initiate contraction of muscle liver source of high energy phosphate liver is the source of high energy phosphate creatine phosphate creatine या फिर I don't know how to pronounce this creatine phosphate liver release high energy phosphate creatine I don't know creatine phosphate release high energy phosphate creatine phosphate liver creatine okay release high energy phosphate release गरेर के बनिन्छ creatine ADP plus P ATP anaerobic respiration or aerobic respiration ATP breaks down into ADP plus P creatine phosphate liver high energy release high energy phosphate then becomes creatine again ऐसा ही होगा ना शायद cross bridge initiate contraction of muscle roll गरिदिँदैछ के हो भन त यो यसले रोल गर्दैछ त्यसलाई this is TP जसले हाइड गर्दै थियो TPI TPT रोल गर्छ सायद calcium binding tropomyosin this one is tropomyosin TPC tropomyosin TPI TPT troponin sliding filament theory it's creatine phosphate liver release high energy phosphate then becomes creatine again creatine phosphate creatine produce in liver breakdown Mg plus magnesium calcium and ATP magnesium ion calcium ion and ATP magnesium ion calcium ion and ATP excuse me magnesium ion calcium ion and ATP so that you can hear यहाँ से सुन लो types of muscles skeletal muscle smooth muscle and cardiac muscle origin of muscle mesoderm 40 to 50% body weight by muscles okay 40 to 50% of body weight is from muscles body weight to 50% body weight by muscle muscle are of mesodermal origin mesodermal or muscle are of origin 40 to 50% body weight two types skeletal muscles then what are the other two skeletal muscle फिर उसके बाद cardiac skeletal muscle cardiac muscle, and smooth muscle. Smooth muscle. Skeletal muscle, striated or stripped, multinucleated, cylindrical structure, unbranched, light and dark band present, oblique bridge plus intercalated disc, oblique bridge and intercalated disc absent, neurotransmitter, ACH, acetylcholine, control, voluntary, regulatory protein, troponin and tropomyosin found in limbs. Okay, इतना सारा जितना याद है skeletal muscle, muscle muscle, skeletal muscle, skeletal muscle, skeletal muscles, unbranched, branched, striated or striated slash stripped, 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 light and dark band present, no oblique, oblige, oblique bridge, no oblique bridge, no oblique bridge, okay, oblique bridge ना, oblique bridge and intercalated disc भी लिख दो, no oblique bridge and intercalated disc, no absence of intercalated disc and oblique bridge. Option number 5. They are unbranched, striated or stripped, light and dark band present, no oblique bridge and intercalated disc. Okay, 5, 6, 7, 8. Unbranched. They are unbranched, striated or stripped, light and dark band present. What is this? Light, unbranched, striated and stripped, light and dark band present. No oblique bridge and intercalated disc. Cylindrical. Neurotransmitter, acetylcholine. Transmitter, MITTR. Neurotransmitter, ACH, acetylcholine. Unbranched हुन्छ, striated हुन्छ या फिर stripped, dark र light and present हुन्छ. Found in limbs. Voluntary control हुन्छ, VOLUNTER, voluntary control. Multinucleated, how can I forget this one? They are multinucleated. 100 myofibrils, right? Embryoma कति हुन्छ? 100 myofibers. Myofibers or myofibrils? Myoblast. Myoblast, myoblast. Fuse where fuse. 1 skeletal muscle. Myoblast, continuous division. Myoblast, skeletal muscle, multinucleated muscle fiber. Multinucleated, okay. Unbranched, multinucleated, cylindrical, unbranched, multinucleated, cylindrical, unbranched, light and dark band, bridge and intercalated disc absent, neurotransmitter ACH, control, voluntary, regular, multinucleated, unbranched, cylindrical, light and dark band present, Oblique and intercalated. No oblique bridge and intercalated disc. Control. Voluntary. Oh, found in limbs. Limbs. Voluntary. ACH. Regulatory protein. Regulatory protein. Troponin and tropomyosin. Tropomyosin. Troponin and tropomyosin. Troponin and tropomyosin. I don't think so. That's rare. Cardiac muscles. Cardiac muscle. Okay, intercalated disc, nucleus, striation present, oblique bridge branched, gap junction and desmosomes. Gap junction, those are gap junction, and there is desmosomes, gap junction. Intercalated disc present, nucleus. They are striated, oblique bridge present, branched. Okay, they are oblique bridge present, branched, striation present, nucleus present, intercalated disc. There is intercalated disc, nucleus, gap junction, desmosomes, gap junction. That is desmosomes. Okay. Intercalated disc, gap junction, striation, oblique bridge present. Let's see. Cardiac muscles. These desmosomes, intercalated disc, gap junction, intercalated disc. This is intercalated disc मै के हुन्छ gap junction हुन्छ gap junction को भित्र desmosomes हुन्छ intercalated disc desmosomes oblique bridge branch desmosomes intercalated disc gap junction for any plus transport gap junction for any plus transport oblique bridge okay branched striation or stripped they have a they are striated or stripped stripped they are uninucleated intercalated disc present oblique bridge present oblique bridge and intercalated disc present striated stripped uninucleated intercalated disc present along with oblique bridge gap junction present desmosomes gap junction के भित्र हुन्छ cylindrical structure but branched they are cylindrical but branched light and dark band present cylindrical structure but branched okay light and dark band present ACH acetylcholine plus epinephrine okay epinephrine neurotransmitter acetylcholine plus epinephrine they are involuntary cardiac muscles are involuntary regulatory protein troponin tropomyosin found in heart troponin and tropomyosin they are found in heart troponin and tropomyosin found in heart tropomyosin and troponin 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 I'm kind of hungry tropomyosin and troponin tropomyosin and troponin tropomyosin and troponin found in heart okay I can write cardiac muscles they are striated, striated. Light and dark band present. Light and dark band present. Striated or stripped. They are striated and stripped. Light and dark band present. Striated, stripped. Light and dark band present. Yes, they are branched. Branched, cylindrical. They are uninucleated. They are uninucleated, branched, right? Cylindrical but branched. They are uninucleated, intercalated disc. Involuntary, first लिखो. Involuntary control. Involuntary control. Intercalated disc. Intercalated disc and intercalated disc and एक और कुछ था, oblique bridge. Oblique bridge. Intercalated disc and oblique bridge. BRIDC bridge present. Intercalated disc and oblique bridge present. Intercalated disc and oblique bridge present. Intercalated disc के भीतर के अनुसार desmosomes, SOMES zones, gap junction. Intercalated disc, oblique bridge, okay. Gap junction present, okay. Found in heart, HEART, heart. Striated, stripped, light and dark band present, branched, cylindrical, uninucleated, involuntary control, intercalated disc and oblique bridge present, gap junction present. What else is that? Oh, neurotransmitter. Transmitter. Acetylcholine, ACH, and epinephrine. Epinephrine, NEPHRINE, epinephrine. These are the two. And regulatory protein. Tropomyosin. Then tropomyosin and troponin. Second slot is also done, okay. Light भी आ गई. They are striated, stripped. They are uninucleated. They have intercalated disc. Okay. Gap junction presence of gap junction. Cylindrical structure but branched. Okay. Light and dark band present. Oblique bridge and intercalated disc present. ACH and epinephrine neurotransmitter. Involuntary. Troponin, tropomyosin. Regulatory protein, troponin and tropomyosin found in heart. They are found in heart, correct. You can type, I guess. अभी तो इतने ज़्यादा लोग नहीं हैं तो तुम लोग लिख सकते हो यहाँ पर. Smooth muscles. कर सकते. 11. 5-minute break, okay? 5 minutes. Good morning, Shubham. I'll just stand, okay? Nidhi, are you there? She was there in the first slot, but I don't know about this one. Nidhi, are you there? Oh, she is there. Hi, Sana. Ima, you didn't wish me, huh? Is it your birthday? Happy birthday, Nidhi. Thank you, Sana. Yeah, it is. ऐसे तूने विश किया? इसने मुझे नहीं बताया तो तुम्हारा बर्थडे है, वरना मैं भी विश कर देती पहले ही. हाय शरू. Binay, I'm preparing for NEET. Break over. slot 3. Okay. ये लो. ले बैठ. I am good. I am good, bro. I'm good. Just wait a second. Net. Good luck, Shri. Good luck, Nidhi. Good luck, शुभम. आई थिंक इतने ही है लोग है ना जो पढ़ रहे हैं. तुम 3. अगर कोई और भी पढ़ रहा है तो गुड लक. 3rd सेशन स्टार्ट है. ओके. 61 मिनट का रख दिया है. ब्रेक पर ही अब चैट्स ओपन होगा. गुड लक ऑल. smooth muscles. Uninucleated muscles. Smooth muscles are uninucleated, spindle shaped, unbranched, light and dark band absent, also called visceral muscle. Oblique bridge and intercalated disc absent. Acetylcholine, neurotransmitter, acetylcholine plus epinephrine, involuntary. They are also involuntary, okay, along with cardiac muscles. And their regulating protein is camodulin, found in body organ. Camodulin. Okay, refresh. Camodulin. Uninucleated, spindle-shaped, unbranched, light and dark band absent, also called visceral muscle. Uninucleated, spindle-shaped. They are uninucleated, they are spindle-shaped, they are unbranched, light and dark band absent. Spindle-shaped, unbranched, light and dark band absent, also called visceral muscle. Oblique bridge plus intercalated disc absent. Acetylcholine plus epinephrine. Involuntary. Camodulin found in body organ. Uninucleated, spindle-shaped, unbranched, light and dark band absent, also called visceral muscle. Okay, oblique bridge plus intercalated disc absent. ACH plus epinephrine. Acetylcholine plus epinephrine. Involuntary camodulin found in body organ. Okay, camodulin found in body organ. Camodulin found in body organ. Regulating protein, not troponin or tropomyosin. It is camodulin protein. Maybe along with them. Body organ, found in body organ. Involuntary, uh, acetylcholine plus epinephrine. Oblique bridge and intercalated disc absent. Light and dark band absent, also called visceral muscle. Unbranched, spindle shaped and uninucleated. Cardiac muscle. Not cardiac muscles, this one is smooth muscles. No striation. No striation. Absence of light and dark band. No striation, absence of light and dark band. They are uninucleated. Tapering end. Tapering end. They are smooth, okay? Also called visceral muscle. VISERL, visceral muscles. MUSCLES, muscles. No striation, absence of light and dark band. Uninucleated, tapering end, also called visceral muscle. So visceral muscle ones, okay? No striation, absence of light and dark band. Uninucleated, tapering end, also called visceral muscles. Involuntary they are. VOLUNTARY, involuntary control. Neurotransmitter, ACH, acetylcholine and epinephrine. epinephrine, okay. Oblique, OBLI, oblique bridge and intercalated disc absent. ABSCNT absent. Oblique bridge and intercalated disc absent. No striation, absence of light and dark band, uninucleated tapering end. Also called visceral muscle, involuntary control, neurotransmitter acetylcholine and EN, oblique bridge and intercalated disc. No striation. Striation no. Okay, I hate them, but I'll have to think about them right now. No striation, absence of light and dark band. Not branched. CHED, branched, okay. Regulating protein. Colistin. कोलेस्टिन तो नहीं था, पता नहीं क्या था. Found in organs of body. यूनिन्यूक्लिएटेड है इनसा. अस्तगफिरुल्लाह. स्पिंडल शेप्ड लिखना था, मैंने क्या लिख दिया इसको, टेपरिंग एंड लिख दिया. स्पिंडल शेप्ड, SPINDLE, spindle shaped, okay. Uninucleated, yes, they are uninucleated. Spindle shaped, they are unbranched, okay. Unbranched, uninucleated, unbranched, light and dark band absent. Visceral muscle, visceral muscle, oblique bridge and intercalated disc absent. Acetylcholine and epinephrine, done. Involuntary control, कैमोड्यूलिन था, मैंने लिख दिया कोलेस्टिन, ये भी गलत है. कैमोड्यूलिन, CHAMO, कैमोड्यूलिन, found in body organ, found in organ of body, okay. Regulating protein, कैमोड्यूलिन. Spindle shaped, okay. Smooth muscles are of spindle shape. Spindle shaped and shaped. Regulating protein, कैमोड्यूलिन, CALMODULIN, कैमोड्यूलिन, protein, कैमोड्यूलिन. My eyes are paining. कैमोड्यूलिन. ACH. Neuromuscular junction affect skeletal muscle. Myasthenia gravis, plasma cell antibody against receptors of neurotransmitter. Antibody against, okay. ACH, acetylcholine, motor neuron. ACH, acetylcholine, skeletal muscle, right. Antibody against receptor of neurotransmitter. Plasma cell produce antibodies. In myasthenia gravis, antibody against receptors of neurotransmitter. Formation of antibody against receptor of neurotransmitter. Neuromuscular junction affect, okay. Skeletal muscles. Autoimmune disorder, fatigue, weakening and paralyzing of skeletal muscle. autoimmune disorder. Okay, autoimmune disorder. Myasthenia gravis is autoimmune disorder. Myasthenia gravis is autoimmune disorder. Fatigue, weakening, and paralysis of skeletal muscle. Fatigue, weakening, and paralysis of skeletal muscles. 1 month में तो नहीं होगा, इतना सारा चैप्टर्स है, 20 चैप्टर्स है शायद, मिनिमम 2 मंथ जितना लगता है भाई साहब। मैं कैसे करूँ? myasthenia gravis, myasthenia gravis, autoimmune disorder, autoimmune, immune disorder, autoimmune disorder। वहाँ से 40, मिनिमम 40 का किया तो कितना होगा? 400 समथिंग होगा। myasthenia gravis, autoimmune disorder, autoimmune disorder, myasthenia gravis, myasthenia gravis, autoimmune disorder, plasma cell produce antibody, myasthenia gravis, autoimmune disorder, plasma cell myasthenia gravis, autoimmune disorder, plasma cell produce antibody, plasma cell produce antibody against AGAINST, against antibody against its own. Okay, myasthenia gravis, autoimmune disorder, plasma cell produce antibody against its own. Autoimmune disorder, plasma cell produce antibody against its own. Myasthenia gravis, autoimmune disorder, plasma cell produce antibody against its own neurotransmitter. Autoimmune disorder. Myasthenia gravis, autoimmune disorder, plasma cell produce antibody against its own neurotransmitter. Receptor. Receptor of neurotransmitter, destroy. Astaghfirullah. Myasthenia gravis, autoimmune disorder, plasma cell produce antibody against its own receptor न्यूरोट्रांसमीटर रिसेप्टर्स, रिसेप्टर ऑफ न्यूरोट्रांसमीटर भी बोल सकते हैं. एंटीबॉडी अगेंस्ट रिसेप्टर ऑफ न्यूरोट्रांसमीटर, अगेंस्ट एंटीबॉडी अगेंस्ट इट्स ओन रिसेप्टर ऑफ न्यूरोट्रांसमीटर. प्लाज्मा सेल प्रोड्यूस एंटीबॉडी which works against receptor of neurotransmitter. Neurotransmitter, neuromuscular junction effect, motor end-plate, skeletal muscles. Autoimmune disorder, fatigue, myasthenia gravis में क्या बंदा था, fatigue, weakening, paralysis of skeletal muscle. Fatigue F8, fatigue F8I GUE, fatigue F8I GUE, fatigue weakening. Fatigue weakening, paralysis of skeletal muscle. Fatigue weakening, paralysis of skeletal muscle. Autoimmune disorder, fatigue weakening and paralysis of skeletal muscle. Autoimmune disorder, fatigue weakening and paralysis of skeletal muscle. Myasthenia gravis, muscular dystrophy मा चाहिँ एउटा प्रोटिन भनिन्छ, dystrophin protein. Important protein, dystrophin protein. Muscular dystrophy, dystrophin protein. Gene mutation, genetic disorder हो. Muscular dystrophy, genetic disorder हो. Muscular dystrophy, muscular dystrophy, muscular dystrophy. Protein हुन्छ dystrophin, dystrophin, TRO, dystrophin protein, dystrophin protein. Dystrophin protein, important protein. Skeletal muscle, okay. Neuromuscular junction. It has a motor neuron, obviously. Motor neuron. Impulse को है ना. Dystrophin protein. कौन सी protein हो? Dystrophin protein. This is dystrophin. Dystrophin. Dystrophin protein. Dystrophin protein. Okay. Gene mutation. Dystrophin protein. Gene mutation. Dystrophin protein ले गर्दाखेरि gene mutation हुन्छ. Gene reduced dystrophin genetic disorder. It is genetic. Dystrophin protein genetic disorder. Genetic disorder. Disorder. Myasthenia gravis, immune disorder हो. Muscular dystrophy, genetic disorder हो. Muscular dystrophy, progressive degeneration of skeletal muscles, mostly due to genetic disorder. Progressive degeneration of skeletal muscle. Progressive degeneration of skeletal muscles. आज तो छुट्टी है वैसे भी तो पढ़ सकते हैं. मैं सोच रही थी कि आज भी क्लासेस है. Progressive degeneration of skeletal muscles. Dystrophin protein. Progressive degeneration of skeletal muscles, mostly due to genetic disorder. Mostly due to genetic disorder के कारणले गर्दाखेरि genetic disorder को कारणले गर्दाखेरि progressive degeneration of skeletal muscles, mostly due to muscular dystrophy. Due to dystrophin protein. Progressive degeneration of skeletal muscle due to dystrophin protein. Skeletal muscles mostly due to genetic disorder. Dystrophin protein means okay, muscular dystrophy में dystrophin protein. Dystrophin protein. Gene mutation. Gene mutation reduces. Genetic disorder. Muscular dystrophy. Important protein, dystrophin protein. Gene mutation reduces. Mutation. Dystrophin protein, important protein. Genetic disorder, muscular dystrophy. Affecting neuromuscular junction leading to fatigue, weakening. Neuroreceptors से क्या करते हैं सर? Destroy करते हैं, so fatigue, weakening and paralysis of skeletal muscles. That is myasthenia gravis, okay? Myasthenia gravis, paralysis of skeletal muscle. Muscular dystrophy. Rapid spasm. SPASM. Spasms. Wild contraction. Spasms. Wild contraction in muscle due to low calcium ion in body fluid. Calcium ion in body fluid. Low calcium ion in body fluid. Tetany. Rapid spasm. Wild contraction in muscles due to low calcium ion in body fluid. Calcium ion in body fluid. ऑन ही नहीं हो रहा है. Red fiber and white fiber. Who is she? Red fiber and white fiber. Red fiber. Diameter small. Red protein. Aerobic muscles. Red fiber are aerobic muscles. They have a small diameter. Red protein. Oxygen storing protein. Red protein is oxygen storing pigment. Red protein. Oxygen storing protein. Red protein. Oxygen storing protein. Okay, small diameter, red protein, oxygen storing pigment. Red protein, oxygen storing pigment. Myoglobin, red protein. Myoglobin is red protein, oxygen storing protein. Na pigment, oxygen storing pigment. Mitochondria has more red fibers. So aerobic oxidation without deposition of lactic acid. Red fiber shows aerobic oxidation without deposition of lactic acid, less sarcoplasmic reticulum, हाँ यही तो है सर, less sarcoplasmic reticulum. Slow contraction. Muscle fiber contract for longer period without fatigue. Muscle fiber can contract for longer period without fatigue. Back extension, back extensor muscle, red meat of chicken leg and thighs, flight muscle of kites. These are red fiber. Okay, red fibers are present in back extensor of muscles. Back extensor of muscle, meat of chicken leg and thighs, and kite, wings of kite, muscles of kite, flight muscles of kite, flight muscles of kite. Diameter, they have a small diameter, they are aerobic, red protein myoglobin, storing pigment, oxygen storing pigment. Okay, myoglobin. Mitochondria has more red fiber or red protein, shows aerobic oxidation without deposition of lactic acid. Red fiber shows aerobic oxidation without deposition of lactic acid, sarcoplasmic, less sarcoplasmic reticulum and slow contraction. Muscle fiber contract for longer period without fatigue. White fiber, large diameter, less myoglobin, less mitochondria. Show anaerobic oxidation and more deposition of, shows anaerobic oxidation and more deposition of lactic acid, more deposition of lactic acid, more sarcoplasmic reticulum. Reticulum, more sarcoplasmic reticulum, fast contraction, shows high rate of contraction for a short period. Example, eyeball muscle, white muscle of chicken breast, light muscle of sparrow. Red fibers, okay, they have a small diameter. Least number of sarcoplasmic reticulum, least number of sarcoplasmic reticulum. Small mitochondria, red protein, myoglobin store O2, pigment, aerobic respiration, small diameter. No period. Work for longer period without fatigue. Work for a longer period without fatigue. Small diameter aerobic respiration rate protein myoglobin store O2 pigment, more mitochondria, less number of cytoplasm, sarcoplasmic reticulum, work for a longer period without fatigue. Small diameter aerobic respiration rate protein myoglobin store O2 pigment, more mitochondria, less number of sarcoplasmic reticulum, work for a longer period without fatigue. Work for longer period without fatigue. No. Lactic acid formation. Big extensor. Small diameter aerobic respiration rate protein, more mitochondria, less number of sarcoplasmic reticulum, work for longer period without fatigue, no lactic acid formation, back extensor muscles. Okay. Each मैंने कुछ तो नहीं लिखा. Slow contraction. They undergo slow contraction. Muscle fiber contract for longer period without fatigue. Okay, muscle fiber can contract. Longer period. Muscle fiber contract for longer period. Muscle fiber contract for longer period. Show aerobic oxidation without deposition of lactic acid, mitochondria, more red protein, myoglobin. Diameter, small diameter. Aerobic respiration, red protein, myoglobin. Mitochondria, more stores oxygen storing pigment. Okay, shows aerobic oxidation without deposition of lactic acid. Aerobic respiration without deposition of lactic acid. Less sarcoplasmic reticulum. Slow contraction. Muscle fiber contract for longer period without fatigue. Back extension muscle. Meat of chicken. Red meat of chicken. Malignant thigh. Who cares? White fiber. White fiber. Red fiber. White fiber. Large diameter. Large diameter. Less mitochondria. Yeah. Sarcoplasmic reticulum. Lactic acid formation and fast contraction. Respiration. anaerobic respiration. Okay. Large diameter, less myoglobin. Less myoglobin, less mitochondria, shows anaerobic oxidation, more deposition of lactic acid, shows anaerobic oxidation, more deposition of lactic acid, less mitochondria, more sarcoplasmic reticulum, less myoglobin, large diameter, less myoglobin, large diameter. Fast contraction shows high rate of contraction for short period. Contraction without fatigue for long period. Red fibers, white fiber में high rate of contraction for short period. 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 Eye bulb muscles, white muscle of chicken breast, flight muscle of sparrow are example of white fiber. Eye bulb muscles. White muscle of chicken breast, muscle of chicken breast, white muscle of chicken breast, eyeball muscle, white muscle of chicken breast, and flight muscle of sparrow, flight FLIGST, flight muscle of sparrow. Shows high rate of contraction. Shows high rate of contraction. Shows high rate of contraction. Shows high rate of contraction with only for short period. So high rate of contraction only for short period. Only for short period. Shows high rate of contraction only for short period. Shows high rate of contraction only for short period. Shows high rate of contraction only for short period. Eyeball muscle, white muscle, flight muscle of sparrow, chicken breast, white muscle of chicken breast, and eyeball muscle. These are the example of white fibers. Fast contraction shows high rate of contraction. Okay, slow contraction, fast contraction. High rate of contraction for short period. High rate of contraction for short period. Locomotion. Streaming of protoplasm, amoeba, paramecium, cilia, two function. One is food collection, another is movement. Movement of food, cytopharynx. Movement of food to cytopharynx, and another is for locomotion, paramecium, cilia, two function. There are two function of cilia, movement of food in cytopharynx, and the other one is movement of cilia into cytopharynx, and the other one is locomotion. Streaming of protoplasm in amoeba. Hydra, tentacles. Tentacles have again two function. Tentacles have two function. First one is capture of prey, another one is locomotion. Capture of prey and locomotion. Amoeboid movement shown by WBC. Macrophages, leukocytes. Macrophages, leukocyte, and microfilament. Streaming of protoplasm. Amoeboid movement shown. Macrophage, leukocyte, macrophage, leukocyte, and microfilament. Macrophage, leukocyte, and microfilament. Macrophage, leukocyte, and microfilament. Macrophage, leukocytes, and microfilament. Cytoskeletal element. Amoeboid movement shown by streaming of protoplasm. Oh my goodness. Amoeboid movement shown by streaming of protoplasm. Amoeboid movement shown by streaming of protoplasm. Macrophages, leukocytes, microfilament. Amoeboid movement shown by macrophages, Macrophages, leukocytes and microfilament. Actin filament, cytoskeletal element. Okay, cytoskeletal element. Macrophages, leukocyte, microfilament, cytoskeletal element. They have amoeboid movement. Macrophages, leukocyte, and microfilament. Ciliary movement occurs in internal tubular organ lined by ciliated epithelium. Ciliated epithelium. Internal tubular organ. Cilia in trachea. Cilia in trachea and passage of ova through FRT. Female reproductive tract. Ciliary movement occurs in internal tubular organs. Internal tubular organs. Ciliary movement occurs in internal tubular organs. Cilia in trachea. Passage of ova through female reproductive tract. Internal tubular organs. Internal tubular organs. Cilia and trachea. Passage of ova through FRT. Streaming of protoplasm, amoeba, paramecium, cilia, two function, movement of food, cytopharynx, locomotion, hydra, tentacles, capturing prey, locomotion. Okay, amoeboid movement shown by macrophages, leukocytes, and microfilament. Okay, ciliary movement, tubular organ of body, tubular organ of body, internal tubular organ, along with cilia in trachea, along with cilia in trachea, along with cilia in trachea. मेरा डेटा ख़त्म होने वाला है, मुझे नोटिफिकेशन आया अभी. Streaming of protoplasm, amoeba, paramecium, cilia, to function, movement of food, cytopharynx and locomotion, hydra, tentacles, capturing prey, locomotion, tentacles, capturing prey and locomotion, amoeboid movement shown by macrophages, leukocyte and microfilament, ciliary movement, internal tubular structure, internal tubular organ, then cilia in trachea and ova, transport of ova in female reproductive tract, passage of ova through female reproductive tract. Ciliary movement occurs in passage of ova through female reproductive tract. Cilia in trachea, tubular, internal tubular organ, cilia in trachea. Okay, muscular movement occurs in tongue. Muscular movement occurs in tongue, limbs and jaw. Muscular movement occurs in tongue, limbs and jaw, etc. Okay, intercalated disc. Uremia. Malfunction of kidney can lead to accumulation of urea in blood, a condition called uremia. इसको uremia बोलते हैं. Okay. इतना सारा पढ़ना है. Movement is one. Movement is one of the significant features. हाँ, तब मैंने कभी किया था. मैंने एक बार टाइमर पॉज किया था और वो रुका ही रह गया. Movement of one of the significant features of living being. Animals and plants exhibit a wide range of movement. Movement is one of the significant features of living beings. Animals and plants exhibit a wide range of movement. Streaming of protoplasm in the unicellular organism like amoeba is a simple form of movement. Streaming of protoplasm in amoeba, simple movement. Okay, Movement of cilia, flagella, tentacles are shown by many organisms. Human beings can move limbs, jaw, tongue, eyelid, tongue, etc. Some of the movement result in change of place or location. Such voluntary movements are called locomotion. Change of place or location. Voluntary movement. Locomotion. Walking, running, climbing, flying, swimming are all some form of locomotory movements. Locomotory structures need not to be different from those affecting other types of movement. For example, in paramecium, cilia helps in movement of food through cytopharynx and locomotion as well. Hydra can use their tentacles for capturing prey and locomotion. Capturing prey and for locomotion. Yes, here it is. Locomotion. We use limbs for change in body. We use limbs. हमने की करसा limbs लाई use करसा for change in body posture. We use limbs for change in body posture and locomotion as well. The above observation suggested that movement and locomotion cannot be studied separately. The two may be linked by stating that all locomotions are movement. All locomotion are movement, but all movement are not locomotion. AR में आने की chances है. Assertion reason. Method of locomotion performed by animals vary with their habitat. Method of locomotion performed by animals vary with their habitat and the demand of situation. Method of locomotion performed by animals vary with their habitat and demand of the situation. However, locomotion is generally for search of food. Locomotion is for search of food, shelter, and mate. Suitable breeding grounds. Favorable climatic condition. Favorable climatic condition to escape from enemies, predators. Okay, locomotion is generally for search of food, shelter, mate, suitable breeding grounds, favorable climatic condition, or to escape the enemies, breeding predator. Types of movement. Cells of human body. Types of movement. Cells of human body exhibit three main. Cells of human body exhibit three main type of movement. Namely amoeboid, ciliary, and muscular. These are muscular movement. Amoeboid cells ले गर्छ. Cells ले कुन ले गर्छ भन्दा macrophage, leukocytes र microfilament. Trachea, ciliary movement and muscular movement. Tongue, limbs, jaw. Some specialized cell in our body like macrophages and leukocytes in blood. Macrophages and leukocyte. Both are WBC. ये तो WBC है macrophage. Exhibit amoeboid movement. It is affected by pseudopodia formed by the streaming of protoplasm as in amoeba. Cytoskeletal element like microfilament are also involved in amoeboid movement. Microfilament actin, alpha tubulin and beta tubulin protein just like you. Ciliary movement occurs in most of our internal tubular organ, which are lined by ciliated epithelium. The coordinated movement of cilia in the trachea help us removing dust particle and some of the foreign substances inhaled along with the atmospheric air. Passage of ova through female reproductive tract is also facilitated by ciliary movement. Movement of our limbs, jaw and tongue requires muscular movement. The contractile protein of muscles are effectively used for locomotion and other movement by human beings and majority of multicellular organisms. Locomotion requires a perfect coordinated activity of muscular, skeletal and neural system. Coordinated activity of muscular, skeletal and neural systems. In this chapter you will learn about the type of muscles, their structure, mechanism of their contraction and important aspect of the skeletal system. I want to sleep but I can't. You will learn about the type of muscle, the structure, mechanism of the contraction, an important aspect of skeletal muscle, movement of our limbs, jaw, tongue, etc. require muscular movement. The contractility property of muscle are used for effectively used for locomotion. The contractile protein of muscles are effectively used for locomotion and other movements by human beings and majority of multicellular organism. Locomotion requires a perfect coordinated activity of muscular, skeletal and neural system. Coordinate muscular, skeletal and neural system. In this chapter you will learn about these types of muscles, their structure, mechanism of their contraction and important aspect of the skeletal system. In this chapter, you will learn about the type of muscles, the structure, mechanism of learn about the types of muscles, their structure, mechanism of the contraction, and important aspect of the skeletal system. Important aspect of skeletal system. Muscles. You have studied in chapter 8 that cilia, flagella are the outgrowth of cell membrane. You have studied in chapter 8 that cilia and flagella are outgrowth of cell membrane. Okay, cilia and flagella are outgrowth of cell membrane. Flagellar movement helps in swimming of spermatozoa. Maintenance of flagellar movement helps in swimming of spermatozoa. Maintenance of water current in canal system of sponges and in locomotion of protozoans like euglena. The cilia and flagella are the outgrowth of the cell membrane. Flagellar movement helps in swimming of spermatozoa. Flagellar movement helps in the swimming of spermatozoa. Maintenance of water current in canal system of sponges and in locomotion of protozoa like euglena. The cilia and flagella are the outgrowth of cell membrane. Flagellar movement helps in swimming of spermatozoa. Flagellar movement helps in swimming of spermatozoa. Flagellar movement helps in swimming of spermatozoa. Maintenance of water current in the canal system of sponges. Maintenance of water current in the canal system of sponges. Flagellar movement, like movement of spermatozoa. Maintenance of water current in the canal system of sponges, and in locomotion of protozoans like euglena. Locomotion of protozoans like euglena. Flagellar movement helps in swimming of spermatozoa. Maintenance of water current in the canal system like euglena. So current in canal system of sponges and in locomotion of protozoans like euglena. I hate her. I hate her. Cellular movement helps in swimming of spermatozoa. Are you irritated with the background noise? Swimming of spermatozoa, maintenance of water current in the canal system of sponges, and in locomotion of protozoans like euglena. Flagellar movement helps in the swimming of spermatozoa. Honestly, I hate her, but we can't help. And in the system of sponges and in locomotion of protozoans like euglena. Swimming of protozoa, maintenance of water current in the canal system of sponges, and in locomotion of protozoans like euglena. Swimming of protozoa, maintenance of water current in the canal system of sponges, and locomotion of protozoans like euglena. Flagellar movement, locomotion of protozoans like euglena. Okay. Muscle is specialized tissue of mesodermal origin. Muscle specialized tissue of mesodermal origin. Mesodermal origin. About 40 to 50% of the body 40 to 50% of body weight of human adult is contributed by muscles. 40 to 50% of the body weight of a human adult is concentrated by muscle. They have special properties like excitability, contractility, and extensibility. They have special property like extensibility, contractility, and extractability. Excitability, contractility, contractility, and extensibility. Muscle is specialized tissue of mesodermal origin. About 40 to 50% of the body weight of a human adult is contributed by muscles. They have special protein like excitability, contractility, and extensibility and elasticity. Four property of muscle. Special properties of muscle: excitability, contractility, and extensibility, along with elasticity. Extensibility and elasticity. Excitability, contractility, extensibility, and elasticity. Muscle have been classified using different criteria, namely location, appearance, and nature of regulation of their activities. Muscles have been classified using different criteria, namely muscles have been classified using different criteria, namely location, appearance, and nature of regulation of their activities. Based on their location, three types of muscles are identified: skeletal, visceral, smooth, and cardiac. Okay, skeletal muscles are closely associated with skeletal components. Closely associated with skeletal components of the body. They have stripped appearance under microscope and hence are called striated muscle. As the activities are under voluntary control of the nervous system, they are known as voluntary muscle too. They are only voluntary muscle. They are primarily involved in locomotory actions and change of body posture. They are primarily involved in locomotory actions and change of body posture. They are primarily involved in locomotory actions and change of body posture. Visceral muscle, located in inner wall of hollow visceral organ of the body like alimentary canal. Visceral muscles are located in the inner wall of hollow visceral organs of the body like alimentary canal, reproductive tract, etc. Okay, located in inner wall of hollow visceral organ, inner wall of hollow visceral organ of the body. Visceral muscles are located in the inner wall of hollow visceral organs of the body like the alimentary canal, reproductive tract, alimentary canal and reproductive tract, etc. They do not exhibit any striation. Okay, they do not exhibit any striation. I got it. बहुत ज़्यादा है भी तो they do not exhibit any they do not exhibit any striations and are smooth in appearance. Hence they are called smooth muscles or non-striated muscles. Visceral muscles are located in inner wall of hollow visceral organ of the body like the alimentary canal, inner wall of hollow visceral organ, inner wall of hollow visceral organ of the body like the alimentary canal, reproductive tract, etc. They do not exhibit any striation and are smooth in appearance. Hence, they are called smooth muscles. Their activities are not under the voluntary control. Not their activities are not under the voluntary control of the nervous system and are therefore known as involuntary muscles. They assist, for example, transport of food through digestive tract, transport of food through assist, transport of food through digestive tract, gametes through genital tract, gametes through genital tract, transport of food through digestive tract. As the name suggests, cardiac muscles are the muscles of heart. Cardiac muscles of heart. As the name suggests, cardiac muscles are the muscles of heart. Many cardiac muscles cells assemble in a branching pattern. They are branched, okay? Many cardiac muscles cells assemble in branching pattern to form a cardiac muscles. Based on appearance, cardiac muscles are striated. Cardiac muscles are striated. Based on appearance, cardiac muscles are striated, branched, and they are muscles of heart. They are involuntary in nature as the nervous system does not control their activities directly. Let us examine a skeletal muscle in detail to understand the structure and mechanism of contraction. Each organized skeletal muscle in our body is made up of number of muscle bundle or fascicle. Each organized skeletal muscle in our body is made up of skeletal muscle. Skeletal muscle in our body is made of muscle bundle. Skeletal muscle in our body is made up of number of muscle bundle or fascicles. Muscle bundle or fascicles held together by collagen fiber. fasciola. Fasciola? Fascia. It's fascia. Made up of number of. It's so hard to say here like this. Each organized skeletal muscles in our body is made up of number of muscle bundles or fascicles held together by common collagenous connective tissue. Collagenous connective tissue layer called fascia. Muscle bundle, fascicle, hold together by fascia. Each muscle bundle contains a number of muscle fiber. Each muscle bundle, each fascicle, not fascia, muscle bundle and fascicle is same. Muscle bundles, fascicles, fascia, okay. Muscle bundle contains number of muscle fiber. Each muscle fiber is lined by the plasma membrane called sarcolemma. Each muscle fiber is lined by the plasma membrane called sarcolemma, enclosing the sarcoplasm. Here we have uh, epimysium covering of muscle, epimysium, dense irregular connective tissue, epimysium, okay, fascicle, fascia, collagen fiber. This is a skeletal muscle. It is a bundle of muscle bundle. Okay, fascia is a bundle of muscle fiber. Muscle fiber. Okay, muscle fiber. Hmm. It's a bundle of muscle fiber. Muscle fibers are surrounded by perimysium. Muscle fibers are surrounded by perimysium. Okay, perimysium, plasma membrane, and called sarcolemma. Okay, muscle fiber, perimysium, sarcoplasm, sarcolemma, multinucleated. Muscle fiber is in syncytium. Multiple nucleus. As the sarcoplasm contain many nuclei. Syncytium. SYNCITIUM. Syncytium. Multiple nuclei. Okay, many multinucleated. Muscle fiber is in syncytium. Muscle fiber is a syncytium. As the sarcoplasm contain many nuclei. Muscle fiber is a syncytium as the sarcoplasm contain many nuclei. The endoplasmic reticulum, that is sarcoplasmic reticulum. Okay, sarcoplasmic reticulum of muscle fiber is the storehouse of calcium ion. Endoplasmic reticulum, sarcoplasmic reticulum of muscle fiber is the storehouse of calcium ion. The endoplasmic reticulum, that is sarcoplasmic reticulum of the muscle fiber, is the storehouse of calcium ion. A characteristic feature of the muscle fiber is the presence of large number of parallelly arranged filament in the sarcoplasm called myofilament or myofibrils. A characteristic features of the muscle fiber is the presence of large number of parallelly arranged filament in the sarcoplasm called myofilament or myofibrils. The endoplasmic reticulum, that is sarcoplasmic reticulum of the muscle fiber, is a storehouse of calcium ion. A characteristic feature of muscle fiber is the presence of large number of parallelly arranged filament. A characteristic features of muscle fiber is presence of large number of parallelly arranged filament in the sarcoplasm called myofilament or myofibrils. Characteristic features of feature a characteristic feature of the muscle fiber is the presence of large number of parallelly arranged filament in the sarcoplasm called myofilament or myofibrils. Each myofibrils has alternate dark and light bands. Okay, each myofibrils has alternate dark and light band. Presence of large number of parallelly arranged filament in the sarcoplasm called myofilament or myofibrils. Dark and light bands on it. A detailed study of myofibrils has established that the striated appearance is due to the distribution pattern of two important proteins. A detailed study of myofibrils has established that striated appearance is due to striated appearance is due to distribution pattern of two important proteins, actin and myosin. The light band contains actin called I band and is called I band. The light band contain actin and is called I band or isotropic band. I band or isotropic band, whereas dark band called E band, anisotropic band contains myosin. Okay. A detailed study of myofibrils has established that the striated appearance is due to distribution pattern of two important. I think I'm sick. Maybe I'm not, but I feel like I am. Each myofibril has alternate dark and light band on it. A detailed study of myofibril has established that the striated appearance is due to distribution pattern of two important protein, actin and myosin. One is actin protein, another is myosin protein. Actin and myosin protein. The light band contain actin and is called I band or isotropic band, whereas dark band called A or anisotropic band. Light band contain actin and is called I band or isotropic band. Isotropic band, I band. Isotropic band, I band. Light band contain actin and is called I band. Light band, actin. I band, isotropic band, whereas dark band, anisotropic band, E band. Okay, dark. Myosin contain myosin. Myosin dark band, anisotropic. Myosin dark band, anisotropic band. Myosin dark band, anisotropic band. Myosin E band, E band, anisotropic band. I band, actin filament present. Light band contain actin and isotropic band. Isotropic band. One is isotropic band, one is anisotropic band, isotropic and anisotropic band, isotropic and anisotropic band. Both the proteins are arranged in rod-like structure parallel to each other and also to the longitudinal axis of the myofibrils. Longitudinal axis of the myofibril. Both are proteins arranged as rod-like structure. Both the proteins are arranged as rod-like structure parallel to each other and also the longitudinal axis of myofibrils. Both the proteins are arranged as both the protein actin and myosin are arranged as rod-like structure parallel to each other. And also to the longitudinal axis of the myofibrils. Actin filament are thinner as compared to myosin filament. Actin filaments are thinner as compared to myosin. Hence are commonly called thin and thick filament respectively. Okay. In the center of each eye band, this is eye band, is an elastic fiber called a Z-line. There is an elastic fiber called a Z-line which bisects it. The thin filaments are firmly attached to Z-lines. Z-line bisect the two light band. In the center of each eye band is an elastic fiber called Z-line which bisect it. The thin filament are firmly attached to Z-line. The thick filament in the A band, are also held together in the middle of this band by thin fibrous membrane called M-line. Z-line ra M-line answer. The thick filament in A band are also held together. Thick filament in A band is also held together in the middle of this band by a thin fibrous membrane. Okay. Thin filament. Just thin filament. The thin filament are firmly attached to Z-line. Elastic fiber called Z-line. Okay. And the thick filament in A band are also held together in the middle of this band by thin fibrous membrane. Elastic fiber or ZJ fiber. Okay. Thin fibrous membrane called M-line. M-line की वो membrane हो, thin fibrous membrane हो, whereas Z-line elastic fiber हो, thin fibrous membrane, thin elastic fiber. The A and I band are arranged alternately. The A and I, anisotropic and isotropic bands are arranged alternately throughout the length of myofibrils. The A and I bands are arranged alternately throughout the length of myofibrils. The A, anisotropic band and isotropic band are arranged alternately throughout the length of myofibrils. myofibrils, muscle fiber, myofibril. The portion of the myofibril between the two successive Z line. This is one of the Z line. This is another. This is M line. Okay. Thin fibrous membrane M line, elastic fiber Z line. The portion of portion of myofibril between two successive Z line, two successive Z line, considered as functional unit of contraction and is called sarcomere. Sarcomere is functional unit of contraction. Functional unit sarcomere. Functional unit sarcomere. Anatomical unit muscle fiber. Structural anatomical unit muscle fiber. Contractile unit. Functional unit. Functional unit. The portion of membrane between two successive jet lines is elastic fiber. Is considered as the functional unit of contraction and is called sarcomere. इसको क्या बोलते हैं? Sarcomere. And is called sarcomere. In a resting state, sarcomere. Okay. The functional unit contraction. Cell line is considered as the functional unit of contraction and is called sarcomere. Functional unit sarcomere. Anatomical unit muscle fiber. Anatomical unit muscle fiber. विल टेक अ ब्रेक. ओके, इस बार थोड़ा लंबा ब्रेक लेंगे. ओके, 10 मिनट का लेंगे. रुको, मैं इतना पढ़ लेती हूँ, उसके बाद ले लेते हैं ब्रेक. Anatomical unit muscle fiber. Structural unit. Resting state. Functional unit of contraction and contraction. Functional unit of contraction. Functional unit of contraction unit. Okay. Contraction is sarcomere. Anatomical unit muscle fiber. In a resting state, the edges of thin filament. In resting state, the edges of thin filament on either side. Edges of thin filament on either side of the thick filament. Side of the thick filament. Partially overlap free ends of thick filament, leaving the central part of the thick filament. Okay. This central part of the thick filament not overlapped by thin filament is called as H zone. Resting phase now. Okay. In resting state, the edges of thin filament on either side of the thick filament are partially overlapped. Filament partially overlap the free ends of thick filament, leaving the central part of the thick filament. The central part of thick filament not overlapped by thin filament is called H zone. Z line, elastic. Z line, elastic fiber, thin fibrous membrane, M line. ब्रेक लेंगे कि, लेकिन ना मैं चैट्स खोलने में थोड़ा मुझे दिक्कत होगी, क्योंकि जैसे ही मैं चैट्स खोलूँगी ना, पता नहीं कैसे कैसे लोग आ जाते. 10 मिनट का बोला था ना, 12 मिनट का हो गया. फिर से 12 मिनट का हो गया. चलो 12 मिनट का ही ले लेते. काफ़ी टायर्ड हो गए. ये हम लोगों का 3rd सेशन कंप्लीट हो गया. ओके, कोई कुछ भी मत लिखना. ओके, कमेंट सेक्शन में तुम लोगों की बकवास सवाल मत पूछना, मैं ब्लॉक कर दूंगी. देखो ना, बोला था ना कोई आके हगेगा. मैं 10 मिनट का ब्रेक लूँगी। तुम लोग नहीं लेना चाहते हो, कंटिन्यू पढ़ना चाहते हो तो पढ़ लो। देखा, बोला था ना ब्लॉक कर दूंगी। तुझे बड़ा शौक है ब्लॉक होने की। पढ़ते तो नहीं हो तुम लोग। एक तो आप किसकी तैयारी कर रहे हैं? मैं नीट की तैयारी कर रही हूँ कौशिक। ब्रेक ले लिया मैंने। ओ तुमने ले लिया, ठीक है। मुझे भी लेना था ना, लेकिन मैंने मुश्किल से ये सेशन कंप्लीट किया। वैसे क्या किया कि मैंने ना 38 मिनट में टाइमर पॉज करके पता नहीं क्या किया था, फिर उसके बाद मैं टाइमर ऑन करना ही भूल गई। तो आई थिंक एक्स्ट्रा पढ़ लिया वो टाइम, लेकिन कोई बात नहीं। मैंने फिर से चैट ऑफ कर दिया, ओके। क्योंकि देखो ना, ये छपड़ी जैसा ना, पता नहीं इसका नाम क्या है। 1 मिनट रुको, चेक करते हैं। जो भी है, कोई घर है शायद, छपड़ी। काश इसकी मौत हो जाए आज जाते जाते, सड़क में इसका ना सड़ ही फूट जाए। और फिर मैं वो पिन करना भूल गई क्या, ब्रेक 10 मिनट वाला। ओहो, पिन भी नहीं कर सकते हम लोग शायद। 1 मिनट में फिर से पिन कर लेती हूँ। हाँ, कर दिया पिन। आई थिंक मुझे ना फीवर हो रहा है फेरेंजाइटिस की वजह से, लेकिन छोड़ो, क्या ही करना। चलो मैं बाहर घूम के आती हूँ एक बार। आज फिर मैंने सोचा कि मैं वो खाऊंगी। वो क्या किया था ना, उस दिन मैंने बोला था कि वो टेस्टी नहीं हुआ था। क्या था उसका नाम, पता नहीं, फ्रेंच टोस्ट शायद किसी ने लिखा था कमेंट सेक्शन। और उसके बाद मैं खूब सारा दवा खाऊंगी। ओके, अभी भी 4 मिनट बचा है। सेशन स्टार्ट करें क्या, क्योंकि मैं चैट्स तो खोल नहीं सकती, वरना 4 मिनट हम लोग बात कर लेते। हमारी ग्रुप ही सिर्फ मॉडरेटर वाली ग्रुप, लेकिन अभी नहीं कर सकते हैं ना। नेक्स्ट सेशन तक ना ये घटा तो मैं चैट्स खोलूँगी। ओके, तुम लोग जाना मत। निधि वाली ग्रुप, निधि, सर्वजीता, एलेक्स, शुभम, श्री, तुम सब में कोई रहे तो रहना। चलो पढ़ते हो के 3 मिनट बचा है, वैसे 60 मिनट का ही रखती हूँ। सिक्सटी मिनट। Good luck everyone. आई थिंक ये वाला सेशन ना लास्ट करिए, उसके बाद मैं चली जाऊंगी, फ़ोन चार्ज करूंगी। ओके, चार्ज नहीं है ज़्यादा, 25 मिनट ही है, मतलब कि ख़त्म होगा 1 घंटे के अंदर अंदर, तो आधा जितना हो जाएगा। Filament. Elastic filament. M line or M line. Anatomical functional unit sarcomere. Anatomical unit. Functional unit sarcomere. Anatomical unit क्या होता है? Anatomical unit. Functional unit is sarcomere. Anatomical unit muscle fiber. I bend. Dog bend. I bend. Light bend. E bend. Dog bend. Light bend. I bend. Light bend. E bend. Dark bend. Okay. E bend. Structure of contractile protein. Each actin thin filament is made up of each actin thin filament is made up of two filamentous actin helical. Each actin filament is made up of two filamentous actin helically one to each other. Made of two filamentous actins helically one to each other. Each filament actin is polymer of monomeric. Each filament actin polymer of monomeric globular actin. Two filament of another protein. Each actin filament is made up of two filamentous actin helically wound to each other. Each filament actin is polymer of F actin is polymer of G globular actins. Two filaments of another protein. Two filaments. Tropomyosin runs close to F actin. Two filament अझै दुईटा actin को दुईटा मतलब फिलामेन्ट छ त्यसमा पनि अझै दुईटा अर्कै प्रोटिनको another protein co-filament. Two filament of another protein, tropomyosin, run close to F actin throughout its length. A complex protein, troponin, is distributed at regular. A complex protein, troponin, is distributed at regular interval. Astaghfirullah on tropomyosin. A complex protein, troponin, is distributed at regular interval on tropomyosin. Troponin. A complex protein, troponin, is distributed at regular intervals on tropomyosin. In the resting state, a subunit of troponin masks the active binding site for myosin on the actin filament. In the resting state, subunit of troponin mask active two filament of another protein, tropomyosin, also run close to tropomyosin also run close to F filament throughout its length. A complex protein, troponin, is distributed at regular interval on the tropomyosin. In the resting state, a subunit of troponin marks the active binding site for myosin. Resting state, subunit of troponin masks active binding site for myosin on the actin filament. इसको नाम हो, यो troponin को नाम हो TPI ना TPT. Troponin, tropomyosin binding troponin. मैं बीमार हो गई यार. In the resting state of subunit of troponin, masks the active binding site for myosin on actin filament. Most probably is distributed at regular interval on the tropomyosin or complex protein. Troponin is distributed at regular interval on the tropomyosin. In the resting state, a subunit of troponin marks the active binding site for myosin on the actin filament. Troponin marks masking of active site. Calcium binding troponin. Each myosin filament is also a polymerized protein. Troponin, tropomyosin, filamentous actin, and actin, thin filament. Myosin, thick filament, is also polymerized protein. Many monomeric subunit. Many monomeric protein called meromyosin constitute many in a 300 monomeric protein, meromyosin constitute the thick filament. Each meromyosin has two important parts. Each meromyosin has two important part. A globular head, meromyosin, okay. Myosin monomer, meromyosin, meromyosin. Globular head with short arm and a tail. The former being called the heavy meromyosin, HMM, and the light meromyosin, short arm and a tail. Light meromyosin. The HMM component, head and short arm, projects out at regular distance and angle from each other from the surface of polymerized myosins. Projects out at a regular distance, angle from each other from the surface of a polymerized myosin filament. Angle from each other from the surface of polymerized myosin filament, and is called cross arm 4 unit, okay. The globular head is an active ATPase enzyme, has binding site for ATP, active site for actin 2. The globular head, I think I'll lie. The globular head is an active ATPase enzyme. And active site for actin. ATPase enzyme, binding site for ATP, binding site for ATP. The globular head is active ATPase enzyme and has binding for ATP and active site for actin. It's okay. Heavy meromyosin component, that is head and short arm, project outward at regular distance and angle from each other from the surface of polymerized myosin filament and is known as cross arm. The globular head is an active ATPase enzyme, and has binding site for ATP and active site for actin. Binding site for ATP and active site for actin. Actin binding site, ATP binding site, head, cross-arm, and the tail. Myosin monomer, meromyosin. Myosin monomer, meromyosin. Mechanism of muscle contraction. Sliding of the thin filament over the thick filament. Mechanism of muscle contraction. तुम कर सकती हो यू ना 39 minutes. Mechanism of muscle contraction is best explained. Mechanism of muscle contraction is best explained by sliding filament theory. Mechanism of muscle contraction. Mechanism of muscle contraction is best explained by sliding filament theory. Sliding filament theory, which states that contraction of muscle fiber takes place by sliding of thin filament over thick filament. Contraction of muscle fiber takes place by sliding of thin filament over thick filament. Contraction of muscle takes place by sliding of thin filament over thick filament. Thick filament माथि बाट thin filament slide हुन्छ. Sliding of contraction of muscle कतिखेर हुन्छ? Sliding of thin filament over thick filament. Contraction. That's the sliding filament theory, which states that contraction of muscle fiber takes place by sliding of thin filament over thick filament. Mechanism of muscle contraction is best explained by sliding filament theory, which states that contraction of muscle fiber takes place by sliding of thin filament over thick filament. Contraction of muscle fiber takes place by sliding of thin filament over thick filament. Thin filament over thick filament. Okay, I got it. Muscle contraction is initiated. Muscle contraction is initiated by a signal sent by central nervous system (CNS). Muscle contraction is initiated by a signal sent by central nervous system (CNS) by via motor neuron. Via motor neuron. A motor neuron, along with muscle fiber connected to it, constitute a motor unit. Motor neuron, along with muscle fiber connected to it, constitute a motor unit. Motor neuron plus muscle fiber. Motor unit. Motor unit. Motor unit. I'll die. I'll surely die. I want to sleep. But I have to complete this chapter. Muscle contraction is initiated by a signal sent by central nervous system (CNS) via motor neuron. A motor neuron, along with the muscle fiber connected to it, constitute a motor unit. Motor neuron, motor, muscle fiber, motor unit, motor neuron, muscle fiber, motor neuron, muscle fiber, motor neuron, muscle fiber, motor unit, motor neuron, muscle fiber, motor unit, motor neuron, muscle fiber. Motor unit, a motor neuron along with the muscle fiber connected to it constitute a motor unit. I wish. Motor unit along with motor fiber. Motor unit is motor neuron plus muscle fiber. Motor neuron plus muscle fiber. The junction between a motor neuron and the sarcolemma of the muscle. Junction between motor neuron and sarcolemma. Motor end plate or neuromuscular junction. Neuromuscular junction or motor end plate. A neural signal reaching the junction releases a neurotransmitter acetylcholine. A neural signal reaching this junction releases a neurotransmitter acetylcholine, which generates an action potential. A neural signal reaching this junction releases a neurotransmitter acetylcholine, which generates an action potential in the sarcolemma. This straight through the muscle fiber cause the release of calcium ion onto sarcoplasm. Release of calcium ion into the sarcoplasm. Increase in Ca level. Increase in Ca plus level leads to binding of calcium with a subunit of troponin. Increase in calcium level leads to the binding of calcium with a subunit of troponin on actin filament and thereby remove the masking of active site for myosin. Using the energy for hydrolysis, utilizing the energy from ATP hydrolysis. Utilizing the energy from ATP hydrolysis, the myosin head now binds. Utilizing the energy from ATP hydrolysis. Utilize the energy from ATP hydrolysis, the myosin head now binds to the exposed active site of actin to form a cross bridge. That is cross bridge. Okay, actin filament, myosin filament. Cross bridge formation, myosin head, formation of cross bridge. magnesium, ATP, calcium, Mg2 plus Mg2 plus calcium, ATP. Stage of cross bridge formation, rotation of head, breaking of cross bridge. सबसे नहीं होगा. Thirty-one minutes. This pulls the attached actin filament towards the center. Okay, this pulls cross bridge formation. Okay, this pulls the attached actin filament. Pulls the actin filament towards the center. Filament towards the center of A band. Towards the center of A band. Towards the center of A band. A band की तरफ towards the center of A band pull कर सके. The Z line attached to this actins are also pulled inward, thereby causing the Z line. The Z line attached to this actins are also pulled inward, thereby causing shortening of sarcomere, that is contraction. Thereby causing the shortening of sarcomere. Contraction. It is clear from the above steps that during shortening of the muscles, during contraction, the I band gets reduced, whereas the A band remains same. A band retain the length, I band reduces, okay, length of sarcomere decreases. The myosin releasing the ADP and PI goes, back to relaxed state. The myosin releasing ADP and PI. I think I'm so tired. कितना कंप्लेन होता है मेरा पता नहीं, मैं खुद ही परेशान हूँ. The myosin releasing the ADP and PI goes back to relaxed state. The myosin releasing the ADP and PI goes back to its relaxed state. A new ATP binds and cross bridges broken. A new ATP binds and the cross bridges broken. A new ATP binds and cross bridges broken. 17.4. New ATP binds and cross bridges broken. Cross bridges कसरी broken छ नयाँ ATP binds, okay. The myosin releasing the ATP and PI goes back to relaxed state. A new ATP binds and the cross bridges broken. The ATP is again hydrolyzed by the myosin head and the cycle of cross bridge formation. This pulls form a cross bridge. This pulls the attached actin filament towards the center of A band. The Z line attached to the actins are also pulled inward, thereby causing the shortening of sarcomere. That is contraction. It is clear from the above step that during shortening of the muscle, that is contraction, the I band gets reduced, whereas A bands retain the length. The myosin releasing the ADP and PI goes back to relaxed state. A new ATP binds and the cross bridge is broken. The ATP binds and the cross bridge is broken. The ATP is again hydrolyzed with myosin head and the cycle of cross bridge formation and breakage is repeated, causing further sliding. Hydrolyzed. The ATP is again hydrolyzed by the myosin head and the cycle of cross bridge formation. The ATP is again hydrolyzed by myosin head and the cycle of cross bridge formation. The ATP is again hydrolyzed by the myosin head and the cycle of cross bridge formation. Repeated, causing further sliding. A new ATP binds and the cross bridge is broken. The ATP is again hydrolyzed by the myosin head and the cycle of cross bridge formation. This is repeated, causing further sliding. A new ATP binds and the cross bridge is broken. The ATP is again hydrolyzed by the myosin head and the cycle of cross bridge formation. And breakage is repeated, causing further sliding. Myosin releasing the ATP and PI goes back to the relaxed state. On new ATP binds and the cross bridge is broken. The ATP is again hydrolyzed by myosin head and the cycle of cross bridge formation and breakage is repeated, causing further sliding. I band reduce. A band remains same. Length of sarcomere decreases. Okay, length of H zone disappears. M line disappears. Kid line. Pull inward. Myasthenia gravis, autoimmune disorder affecting neuromuscular dysfunction, leading to fatigue, weakening, and paralysis of skeletal muscle. Autoimmune disorder. Myasthenia gravis. Okay. Muscular dystrophy is genetic disorder. Degeneration of skeletal muscles. Of skeletal muscle mostly due to genetic disorder. Muscular dystrophy, genetic disorder. Myasthenia gravis, autoimmune disorder. Tetany, rapid spasm, wild contraction spasm in muscles due to Lucy plus. in body fluid. Calcium ion in body fluid. Inflammation of joints. The process. The process continues till Ca++ ion are pumped back to the sarcoplasmic cisternae. Okay. The cycle of cross-bridge formation and breakage is repeated, causing further sliding. The process continues till the calcium ions are pumped back to the sarcoplasmic cisternae, resulting in the masking of actin filament. This causes the return of Z line back, elastic fiber. मुझे काफ़ी तेज़ फीवर आ रही है, पता नहीं क्यों। मैंने कुछ खाया भी नहीं है, लेकिन फिर भी फीवर आया। अगर मैंने कुछ ठंडा पिया होता और फीवर आता तो भी मैं मानती। This causes the enter of Z line back to their original position, relaxation. This causes the return of Z line back to their original position, that is relaxation. Relaxation. This causes the return of Z line back to their original position, that is relaxation. This causes the return of Z line back to their original position. Relaxation. The reaction time of fibers can vary in different muscles. Repeated activation of muscles can lead to accumulation of lactic acid due to anaerobic breakdown of glycogen in them, causing fatigue. Okay. Muscle contains a red color oxygen storing pigment called myoglobin. Myoglobin content is high in some of the muscles, which gives reddish appearance. Such muscles are called red fiber. Which gives reddish appearance. These muscles also contain plenty of mitochondria, which can utilize the large amount of oxygen stored in them for ATP production. Plenty of mitochondria which can utilize the large amount of oxygen stored in them for ATP production. These muscles therefore can also be called as aerobic muscles. Okay. On the other hand, some of muscle possess very less quality myoglobin. Less quantity myoglobin, and therefore appears pale or whitish. बिल्कुल मेरी तरह pale. These are white fibers. Number of mitochondria are few in them, but the amount of sarcoplasmic reticulum is high. Amount of sarcoplasmic reticulum. मुझे यानी के पास जाना है. Amount of sarcoplasmic reticulum is high. They depend on anaerobic process for energy. On the other hand, some of the muscles possesses very less quantity of myoglobin. And therefore appear pale or whitish. These are called white fiber. Number of mitochondria are also few in them, and amount of sarcoplasmic reticulum is high. They depend on anaerobic process for energy. H1 M-line disappear. बहुत खराब लग रहा है. Relaxed, okay. H1 Z-line sarcomere. I band. E band. Contracting. H zone decreases, I band decreases, A band remains same. Maximally H zone disappear, I band decreases. A band remains same. M line disappears. H zone M line disappears. So length of sarcomere decreases obviously. Maximally contracted man. I'll go अब ओके क्योंकि 15 मिनट अभी भी बाकी है फोर्थ सेशन का, लेकिन मैंने तब टाइमर वो करके मैं भूल गई थी ना टाइमर ऑन करना. आई थिंक आई हैव टू टेक रेस्ट. और मेरा चार्ज कितना है? 12% ही है, तब 25 था ना. हाँ 13% चला गया. वैसे मैंने ये चैप्टर कंप्लीट नहीं किया, मैं आके करूँगी. स्केलेटल सिस्टम करना है अभी भी, पर अभी के लिए मैं जा रही हूँ. ओके निधि भी हो क्या? तुमने बताया नहीं आज निधि का बर्थडे था शुभम. मेरा तो पूरा ही बचा है. लाइक मेरा 25% भी कवर नहीं है हुआ है पूरा सिलेबस में से. अगर इस चैप्टर की पूछ रही हो तो स्केलेटल सिस्टम इसका बताया. और एनसीईआरटी प्लस नोट्स दोनों कर रही एक साथ. हाँ नोट्स के बिना समझ ही नहीं आता मुझे एनसीईआरटी, पता नहीं क्यों. सब लोग बोलते हैं एनसीईआरटी इजी होता है, मेरे लिए नहीं होता है. मुझे तो लिविंग वर्ल्ड का भी चाहिए होता है. कल निधि पूरे दिन स्ट्रीम में थी तो किसे पता था? ओ अरे यार बताते तो सब लोग विश कर देते ना उसको. तेरी उसकी तो ज़रूरत नहीं है, मुझे एडवाइस की तो ज़रूरत नहीं है. ड्यूरेशन ना लग देते हैं 20 मिनट. अब ये लोग नहीं कर पाएंगे, गाली नहीं दे पाएंगे, पता नहीं. देखो तो इन्हें जब मैं रहूं तो नहीं बताओगी. लाइक 80%. मुझे समझ में नहीं. लाइक 80+ डे डन. वैसे मेरा रिवाइज भी करना है, रिवीजन भी काफ़ी करना है. मैं कितनी बार रिवीजन करती हूँ फिर भी भूल जाती हूँ सब कुछ. और बायो तो सब्जेक्ट ही ऐसा है ना कि बहुत ज़्यादा रिवीजन करने पर भी भूल जाते हैं। मैं चली जाती हूँ अभी, ओके, क्योंकि मुझे ना काफ़ी तेज़ बुखार आ रहा है, पता नहीं क्यों आ रहा है। हाँ देखा मैंने तुम्हें डॉक्टर लवर। हाँ बताओ सना। मतलब स्ट्रीम लाइक 85 हुआ है। ओ ओके ओके निधि, समझ गई। सुनील छेत्री को जानती हूँ, हाँ मेरा ही तो चाचा है। तुमने देखा नहीं, मेरा ईमा छेत्री, उसका सुनील छेत्री। ओके निधि। बाय ऑल। दी क्या पढ़ रही हो? अभी तो जा रहे हैं, अभी तक पढ़ा था, तुम तब नहीं थे। भाई मैं चली गई, ओके। सुनील छेत्री, हाँ देखो ना सरनेम छेत्री उसका है ना, तो सब लोग मुझे यही पूछते हैं, इंडियंस लोग स्पेशली, क्योंकि नेपाली में तो छेत्री बहुत ज़्यादा लोग होते हैं ना, लेकिन इंडियंस जब भी आते हैं तो वो लोग मुझे पूछते हैं कि सुनील छेत्री को जानती हो। लाइक अदर छेत्री होता ही नहीं है, सिर्फ एक ही छेत्री है। मैं भी स्टडी कर रहा था। ओ ओके ओके, अभी बाय, ओके बाय बाय।